Thank you, Jamie. Jamie is right. That's my job, to play with FME, and that's actually how I got my job. For those who don't know, 12 years ago, I came to Don and Dale, still not working at SAFE, and told them that, you know what, FME is much better game than Duke Nukem and Quake, and they hired me. And the fun part is that it's not a joke, it's serious, like that's how it happened. So, and since that time, I was playing FME, usually, trying new functionality that our developers add to FME, and, having a chance to pick whatever I like most and to play with that, whether it's new vector or raster or point cloud functionality. Sometimes it works a little bit differently. Sometimes I just play with functionality that does not exist. I just find some way of doing that, and then I just show that it works really well, and we can then have it as a standard functionality. So some examples can include feature merger. You probably all know that. Transformer, it is slow, but years and years ago it was much, much slower than today. So I had a pretty small data set, about 500,000 roads in the United States, and we just wanted to somehow overlay them with maybe counties. And that would take about 20 hours to run just some simple joining query. So what I tried to make a SQLite database and load everything into that database and then just run the query. Databases are good at that. And got my results in 20 minutes. So that was an obvious progress. And I'm not saying that that was my initiative, I just tried that, and that was a really good proof of concept. And then behind the scene, we changed how feature merger works. So then with point clouds, I did something similar. So I created some scenarios and some fake transformers. It could work like that, and you will get that. So, and then we implemented that functionality. And since that time, I really love playing with point clouds. But this time, I'm going to talk about ThreeJS, which is a JavaScript library, which is really good for visualization things. So Data Inspector is really great when you would like to see your geometries from different formats and in 2D or in 3D, and then it's really good for inspecting. You can go really down to your geometry, to the atomic level of geometries, which you cannot do with other products. But when you speak about fancy visualization, it's not that great, really. So, that's what this slide was about. So would it be really cool if you could just, you can read this inspirational quote from Douglas Adams, Hitchhiker's Guide to the Galaxy. I read this in English for the first time a month ago. I read that in Russian like 20 years ago. So, and I really, really enjoyed, not the plot, because I knew it really well, but the language itself. It was so amazingly great and so funny. So I think this really fits my presentation today. That's what I'm going to show you. So how we can use this ThreeJS within FME. So I'm going just to show what I did for myself, and I can share my results with everyone. I'm not publishing it. I will tell why later. So why don't we create some surface and fly over it? So how we can do that? I had a training session yesterday where I was talking about rasters and satellite imagery, and all the participants did something very interesting. You will see that. But all the data, or a lot of data, is now free and available for everyone on Amazon. Earth on AWS, it's a great program where you can find satellite imagery like Landsat or Sentinel and DEM data and a lot more. So you can just get some data from there. And yesterday I talked how you can do that with FME or even without FME. So then with the simple workspace, you can assemble a 3D surface. Here I just read some satellite bands from Sentinel, European satellite, 3 satellites orbiting Earth and delivering images every 5 days for our latitude. Then I assemble those bands together into a single RGB or infrared image, and then I download, you can see there, some DEM and make a surface that looks like that. That's lower mainland. We see it somewhere around here right now. So that's what you can create. You don't need anything, well, just FME to create things like this. So, and then when you have that surface, you would like to visualize it in, well, in a fancy way. I created this custom transformer, which is called ThreeJS renderer. And you can see that inside it's not small, but it's not really big, and it's not really complicated if you go there. So here's what I did. Yes, still, some JavaScript code was needed, and I wrote it. And I started learning JavaScript in around maybe 1997 or 8, and that's where I stopped, well, ended learning it, so my knowledge is really, really limited and really, really outdated. But you know, it's pretty simple. You have, for example, 3 lines to define your scene, 4 lines to define your camera, and there are many examples online. You can just find them. So that's what I did. So here I define my scene, here I define my camera, here I define my geometry, and then that's it. So, and then to write the geometry, it's a little bit hidden in FME in JSON templater, which is not really obvious, but it can write geometry which is suitable for ThreeJS as a file with all the textures. So, and I don't even think it was included into documentation, but we can do it. So then that's how the snippets of code can look like. So here I define a camera. I say, I create a new camera with focal length like that. It can look from here to here. That's the distance of your depth, and then where you should position it and where it should look, and then just put it into your scene. That's it. So, and then I aggregate just a single, so I create those snippets with attribute creator. Then with aggregator, I aggregate into a single HTML, and then just call it within Workbench with system caller. So I don't even have to go separately and open my results. So, and now I can show you how it works. I will switch to my workspace, this one, here it is. I will run it, it runs for about 30 seconds. So here I just read my geometry, scale along Z, so that it just, you know, exaggerated along Z. And then send the geometry to ThreeJS renderer. I will run this, and here I will show you some parameters. We don't need this actually, so I will show you how it works inside, and you can use it for basically any application, any document that has a default application. Then basically how you would like to navigate, fly over or orbit, or maybe pan. There are many possibilities, and a few other things. Whether I should attach light to the camera, and it's ready actually. But I will go inside the transformer to show you a few things. So it's not that scary. So here I just define the header of my HTML. I can show you if I go here. It's just as simple as that. If you know HTML, you can, you know, easily understand what is going on. Here I just say I will have a scene where something will be developing. And I also create here a sort order, which is null, 0 here, and that portion will just be the first in my final HTML. Then here I load geometry, again, just a short snippet. I made the font really large yesterday for my training so people can see it. So basically, I read some JSON which FME wrote for me in this transformer. So that's all you need to create a JSON geometry for your scene. And again, here I have my sorting order. So then I define the surrounding, for example, sky, or you can, you know, place yourself in some dungeon or anywhere in the world. You just have to find a nice 360-degree photo. And then some camera settings, we talked about them. So again, it's just a short JavaScript code. So, and I don't really understand much about that, so I just copied some pieces and inserted the variables, so that's it. So after that, I simply sort by that sort order so that all the pieces come together in a nice way and aggregate them into a single HTML. That's it. Then I write it to some folder and with system caller, where you can just say Explorer and the address local address or web address, and it will be visualized with your default application. In my case, it's Chrome. So if it would be a PDF, it would bring up the Adobe Reader, and you will see your PDF. So with this system caller command, really good one, I think. I love it. So in this case, you don't need. So, and that's what we get here. Where is the geometry? Here it is. And now we can simply fly. It's a flight simulator, but a really good one, because we have all those controls which when you have plane simulators, they're really great, but people don't want that. They just want to fly, and the controls are just the necessary evil. People would like to fly like birds or like kites. Yeah, so I even created. Sorry, I pressed something. Yeah, that's the same thing. Yeah, and what is nice thing, so if I go back to my workspace, just to show you one thing, you can immediately, right from your workspace, instead of just visualizing it in your browser, go to, for example, S3 Uploader, put it into Amazon machine, and then that will generate a link for you, and you can send your link or stream back, and then just by uploading this workspace to FME Cloud, you can have a service that would generate something for your customer. They can, for example, click on a map. You will go to Amazon storage, grab some Sentinel data. You will grab some DM data. You will assemble this model, and you will stream back what you just saw, where you can fly over something. So the only problem, it won't do that fast. It will take maybe a few minutes, but not hours. And then it's all free. Well, except FME, of course. So, but so as I said, it works everywhere. It works on your phones, in any modern browser. So, and I just made a short video how I fly over lower mainland. It doesn't want to go to the full screen. Okay, and PowerPoint does not play the music, and that's good, because I wouldn't tell you who the author and the performer is. No way. So that's we fly over the Barrard Inlet, and then that's Burnaby Mountain on the right, and then I will fly over my house in a few seconds. And Jamie also knows that area well. And yeah, right now, yeah, so we passed my house, the last house on the street, and then that's Indian Arm. Now we turn to Seymour Mountain, and then we have this beautiful moon. And go up, so really nice. So full screen would be better, of course. I should do it next time. Yeah, I'm delivering this presentation once again on Friday, so make sure that it runs full screen. And then we are back to Kitsilano Beach, where we started. Yeah, that's what I created with that. So, but of course, you can use ThreeJS for many things. So I created lots of different examples, and I started with that one where I just wanted to show something to my kids. And I got so involved that I just kept playing with that for a while, for a few months, I'd say, and I was paid for that. Yeah, but doing that example with Earth and Death Star, I found like 10 different bugs, really bad ones, and that's what I do. I play with it, but it's serious. Like, first of all, you probably like it, and you think maybe that's good if we could do the same thing. And then the second thing, of course, I find a lot of problems with FME, which I file and they get fixed, and then you get a better product. So unlike simple testing where you have A and you should get B, I tested a little bit differently. So what would happen if you just take the Death Star and move it closer to the Earth? So, and that's what happened. I found lots and lots of bugs. So, and then I put myself inside you can see the snow globe. That was an interesting project. We did that, I think, a year and a half ago as a Christmas present for our customers. Then for our clients, the city of Surrey, I put a piece of their city inside this snow globe. Then I tried visualizing point clouds and making some, this office. You can see it on top. I can go to those worlds and show them live. So, for example, here, that's our safe office. So this, like a Mercury circle, it's where you're located, and that's the very end where our documentation department is. So here sits Dave. Yeah, he writes documentation. So, and then you can just click like in Google Street, right? They had something like this one. You can go like that from one location to another. It's very simple. I created this with a simple camera, $300 camera, which takes the 360-degree pictures. So here I make my coffee every day. Here, this is the station. I'm trying to get to my office now. So you can see me hiding, not very successfully here. And then I'm almost there. So my office is here. Yeah, I can even go inside. So it's very easy. Again, I just assembled a few pieces. I wrote some JavaScript, but then I just used FME for generating all those worlds. So like 40 different HTML files, and how I drew the map, connected all the points, extracted all the information, and just filled the variables with FME. So another example is this. Again, our office, but like, Quake style. Well, the view is not that beautiful, of course, but that's the freedom, right, of being a creator of such thing. Well, but you can use it for serious things like escape routes, right? You can see where you should go. So, and those are real things. So I added them exactly how they are. But I can go through walls here, so fire wouldn't be a problem for me. So, and I can get to my office again. It's here. So I stopped working on this project because we are moving to a new building, and it makes no sense. Maybe there's some memorial, old memories, something like that. So I also tried to visualizing point clouds. So here is an example. So and you see, it's just browser. You don't need anything. You can take those links. If you get my presentation, you can just click on the link and you will get there. You don't need anything for that. Nothing to install. Just do it and just use it and just share it. Up to 750,000 points you can easily stream to your browser. Well, at least on my machine that worked pretty well. But it is old. It's almost 5 years old, my desktop in the office. So, and it works pretty well. So you can see here an example of a point cloud. So, going back to my presentations, so those are the links. So if you get it and play with it, just you can go and check them. That's what I did. I put them on Amazon, and they are available for everyone to have a look. And the virtual reality contest that we made for this conference, again, that's you all should have those things. You can try to find those sheets around the convention center. You should see 7. And 2 more, we will announce them later somehow. And you put your phone inside, and you get into this virtual reality. You should find a password inside, and then submit them on the fme.ly/contest page. And please do it, because I would like to hear some feedback that you like it. So I'd be pleased. So. But that's the problem. It's still I can do that, but not everyone can do that, because visualizing it locally requires having a web server running, and you should know how to do that, and I don't. I just installed the FME server, and that worked for me. But if you don't have that, then how it will work for you? That's why I don't publish the results. I can share it with everyone if you would like to, but they're not publishable yet, not in that stage where I can just simply say, here's a standard transformer or custom transformer, use it. So we have this idea on our knowledge base. You can go there and vote for that and say, you know what, I would like to have it as well. I would like that ease with which I can share this data to show it to everyone. So because it's much better than anything else, than Data Inspector for sharing, I mean, or PDFs. I used to say that, you know, PDF 3D is so great because it's so easy to ship, it's so easy to share your information, but at least you need Adobe. But people don't necessarily have them, and it's not very performant. Performance-wise, it's not very good. So, but this is I really love it. And then you have lots of possibilities for light and for camera and for navigation, much better than in PDF 3D. So that's my presentation. So if you have any questions, I can answer. And I'm here all the time. I'm in the doctor's office in the mornings. So stop by. We can talk. Thank you.
I got a question. Have you hit the browser limits much, or are you actually?
Well, if we speak about this example, I can show you. Well, this texture is about 70 megabytes, so which is pretty big, right? So it's about 8,000. Well, it resamples it to 8,000 by 4,000 pixels, I think, for this particular one. So it's pretty big. Eventually, you will hit the limitation, and I don't know what the limitations of the ThreeJS are, but for my work, it mostly works okay. Yeah, yes, yeah, and with point clouds, as I said, 750,000 points, and then I began getting crashes above that.
Mm-hmm.
Yeah.
Cool.
Yeah.
Good. Any other questions? One over here. Yeah.
They have, so if you go to threejs.org, you will see like a million examples, and some of them include point clouds. And they have PCD loader, which is just another 2 or 3 lines of JavaScript code. I wrote my own PCD writer, which is, it's a text point cloud format. So it was easy to write with just a simple FME with a few transformers.
Not really a question, but a feature request. Seeing you putting together HTML stubs with the sorter to point into there would be really nice to have something like an HTML templater.
That's the idea. Yeah.
XML templater because it's not really valid XML. If you want to perhaps put some additional HTML code.
Yes, that would be much better. Yeah.
The HTML reporter already generates. You want to put some additional block somewhere into it. You have to really figure around with some.
Yes. This is the idea. I talked to Dale about that, and he sees it that we just add another functionality to our HTML report generator. You can have it already. You can have a table there, an image. So just another entry will be a ThreeJS window within your HTML. So and then that you will get within your HTML page, and that it will be valid and everything. So yeah, that's a good thing. Yeah.
Okay, thank you.